Welcome back to CS111. In this lecture, we're going to continue looking at array-based bag implementations, but now, rather than restricting ourselves to a particular type, we're going to see how we can make our bag accept items of different types by using generics. I'd like to start off by looking at how we can make our bag be more flexible in terms of what types of data we can store. In the implementation that we've looked at over the last two lectures, we designed a bag that is intended to store strings specifically. So we designed an interface called string bag interface, and it's taking string as its parameter for when we go and add and remove things. And then, like, for example, when we go and create an array with toArray, it's returning strings. And we went and implemented that interface in the class string array bag. Because everything in our function parameters and function return types and all was set up to work with strings, if we want to be able to store some other type of data, we're going to have to create a new interface and a new class to implement that interface to do that other type of data. Having to go and create separate interfaces and classes for every type of data that we might want to store is really kind of problematic. There's a lot of work with that. That's going to cause us to have to maintain a lot of code. One solution to this problem is that rather than going and storing strings, we can go and store objects. In Java, object is considered the base class. Every type of data that exists in Java inherits the object class, whether it be a string or a class we make ourselves, or something like dealing with numbers. Those all go inherit from objects. So if we go and set up our code so that we're going to store and work with objects, we'll be able to go and use any type of value that we can go ahead and store then. To go and convert things from working with strings to working with objects is actually a pretty straightforward process. We basically just need to swap out type references in our code. So to do that, we're going to head over to Eclipse and work through an example. To create a bag that will store object type items, we want to start off by going and importing the starter code that's provided for this lecture. I've created a new workspace here in Eclipse, and I'm going to go to the File menu and go to Import. Under General, I want to choose to import existing projects into Workspace. I'll click Next. And I want to choose the radio button to select an archive file because the starter code is packaged as a zip, which is considered to be an archive. I'll click Browse, and I'm going to go to the desktop, which is where I downloaded the starter code. Go ahead and select that zip file, and you can see that inside there are two projects. We're actually going to use both of them as part of this lecture. I'll go ahead and click Finish, and they'll get imported here. Here in Eclipse, I'm going to start off in the object array bag project that we imported. We're going to change this over so that it stores objects rather than strings. And the first step in that is just making sure that our names actually reflect the fact that they're not specifically tied to strings anymore. I'm going to go and rename my interface, my class, and my package to get rid of the word string in them. I'm going to rename using the refactoring tool that Eclipse provides, and most of your development environments have something comparable to this. It's normally called refactoring. What refactoring does is it goes and updates any reference to that item to use the new name. So it'll go into multiple files and go and make the changes if it needs to so that everything points to that new name. If I need to go and rename a file, for example, to correspond with the new name, Eclipse is going to take care of that too when I go and refactor. Let's start off by refactoring string bag interface. I'm just going to right click on the file itself. I'm going to go to refactor and go to rename. And I'm just going to change the name here so that it says bag interface instead of string bag interface. And I'll click Finish. So it renamed the file. If I open the file, it renamed the interface inside. And then if I look at string array bag, which goes and implements the interface, it also went and renamed it there. So any place that that interface is being mentioned, like back in my main class, it all got updated with the new name. I didn't have to go and search and make all those changes because it's really easy to go and miss something if you're going and doing this manually. Go ahead and close those files back out. Let's also go and rename the string array bag package. Let's go and get rid of string in the name. I'm going to follow the same process. Right click on the package, go to refactor, rename, and I'll just get rid of the word string there from the name, and I'll tell it OK. It went ahead and renamed things. And then I'm going to go and do string array bag, the class. So I'm going to take the Java file that contains it, right click, refactor, and rename, and I'm going to call this just array bag now. Go ahead and click finish, and it's going to make that change there in that file. And like in main, where I go and create a new, used to be string array bag, now it's doing an array bag instead. The other part of going and swapping out strings for objects for what I'm storing in my bag is I actually have to go through the code and basically change any reference from string to say object instead. I'll start off with my interface, and I'm gonna go and look for any place that I have a parameter or a return type that's of type string. I'm gonna change it to object. If I'm referring to strings and comments, I'm going to change that too. So when I have a description here of what the interface does, we're going to say that we're storing objects rather than strings. And then I'm just going to go and look through each of the method headers here. So like add is now going to take an object called item rather than a string called item. We'll do contains, count of. For the version of remove that doesn't have any parameters, it's now going to go and return an object. The version of remove that takes a parameter will take an object now. And when we go and create an array, we're going to go and return an array of objects rather than an array of strings. Now, when I made those changes and saved my file here, you can see all these errors popped up, and they're all in my class file. Those errors come from the fact that the methods there no longer match the methods that are in the interface, because one of them says string, the other says object. So I'm going to go into my array bag class, and I'm going to go and make the corresponding changes over there. I'm just going to start at the top and work my way down. So we'll update the comment for the class, and then we're going to go and just look through this code here and go and swap out anything that we see. So for example, where we have the protected field called bag, that's a string array, we're going to make that be an object array. We'll want to go through and swap out for the methods any of the parameters or return types. I am also going to go and eyeball the code that's in the body of my methods. So for example, here in the constructor, where we're going through and initializing our array, it's now going to be an object array, not a string array. We'll change the parameter for the add method, for contains, for count of, for remove element. So there are some cases here, like with remove element, where the method is something that is specific to array bag. It's not part of the interface, but for consistency, since everything is dealing with objects now, I need to go and change it over to objects as well. We go and have our version of remove that doesn't take any parameters. That's going to go and return an object now. Get index of will take an object. Remove is going to take an object. And toArray is going to return an object array. Now, in the code here, the only other case where we might really need to think about what particular type of array we're dealing with, and that's really kind of the big concern, is in the toArray method here. The copy of method here that we're going through and using from the arrays class, this static method to go and duplicate our array for exporting it, it's got a variety of different versions of copy of, and it's going to go through and do a copy of whatever type it is. So I don't actually need to change anything there. I'm going to go ahead and open up my main class, and this is what we wrote in the previous lecture, and I'm going to run it. You can see that my code runs here, and it's going and storing these different values that we said with the names of WVU campuses. One of the biggest advantages of using object as the type that our bag is designed to work with is that it can go and accept an item that's of any type that inherits from object. So essentially anything that's not a primitive value. And considering that the primitive values like int all have wrappers like integer that go and inherit from object, essentially we can store anything. That's also the biggest shortcoming of this approach. Let me show you an example here. So we have this bag that's got a series of strings now. Because I'm going and using object as a type here, it is also perfectly legal for me to go and add the number 5 to the bag. Now, this 5 here right now is actually an int, but what's going to happen is Java is going to look, see that I'm going and passing it to a method that doesn't accept ints, but it accepts objects, so it's going to actually convert it to the wrapper class integer automatically. But when I go ahead and run this code, you'll see that the value got added, it got printed out the same as the other items that I'm putting in there. Sometimes this can be useful functionality, but most of the time, we really only want to have the same type of data stored in our bag. Now, there are some ways around this if I want to be able to restrict the type of item that I'm going and storing in my bag. I can, for example, write some code to go and check to see if an object that I'm passing is of a particular type. The problem with that solution is that those checks occur at runtime when my program gets executed. By that point in time, my software could be installed on a whole bunch of different machines. If there's a bug, it's much harder to catch that way. If it was a compile time issue where I was going through and using a specific type that the compiler could catch, I'd be a lot less likely to have that sort of bug crop in. So this method will allow us to go and use a variety of different types with our data structure, but it's got some weaknesses that maybe is not the best way to go. There is a better solution to our problem, and that's to use a language feature that is known as a generic. Generics are basically placeholders that we go and put in our classes, interfaces, and sometimes methods that allow us to specify a particular type that we're going to substitute in. So we don't have to hard code into that particular method or class what type of value it's going to get. We'll go and specify the type we want to use when we go and instantiate that class or go and call that method. So when we go and use that class or method, we have to provide a type. And the type that we specify is going to be substituted in at compile time, which means that any of the values that we're trying to go through and, for example, pass to our add method, if they're incompatible, they're going to be detected at the compile time, not at runtime, which makes it easier for us to go and debug problems. Let's go back to Eclipse here, and we'll take a look at how we can go and do some sample code with generics. Let's go ahead and create a new project in Eclipse to use for our example. So I'm right-clicking in the Package Explorer, going to New, and choosing a Java project. I'm going to call this project Generics, and I want to make sure that the checkbox here for creating module-info is unchecked. With that done, I'm going to click Finish, and we get ourselves a project. Let's go and create a new class under the source folder. So I'll right-click, go to New, and click on Class. And I'm going to call this class Generic Math. We don't want this file to have a main. We'll go and create another file that will have our main here shortly. We'll go and click Finish. So let's say that we have this class Generic Math, and we're going to use this to store some numbers that we'll eventually want to be able to do math operations on. Inside the class, I'm going to create a private field that I'm going to call value. And right now, I'm not sure if I want to deal with integers or doubles or float or something else. I'm going to go and just make this be of type object. That'll give me flexibility in what I'm going to go through and place here. I'm going to call this field value. I'll create a constructor that's going to allow me to specify an initial value. So I'm going to go and set this dot value, which is my field, equal to value, which is the parameter in this local variable we're going and passing in here. I'm going to create a getter method. So this one's going to be public. It's going to return type object. We're going to call it get value. And that doesn't need to take any parameters. It's just going to go and return this dot value. We can create a setter, and this one can be a void method. Don't need to return anything, but we do need to be able to set the value, and we're going to take as a parameter the value we want to go and set it to. So this will be a type object, and we'll call this one value, and then we'll go ahead and store that value that was passed in. This dot value equals value. And then let's go and create one more method. We'll make this one be public. We'll have it be void as well. And we're going to call this one print value. And it doesn't need to take any parameters. And we're going to go and call system.out.println and print out the value that's stored. So I've got my basic class set up here. And I'm going to go and create another class where I'll place my main. So I'm going to right click on the source here. We're going to go to new class. I'm going to call this class main, and I'm going to check the box so that Eclipse will go and create a stub for my main method. Over here inside the main, let's go and create an instance of our generic math class. So I'm going to say that I want generic math, and I'm going to call this generic as the name of the variable, and I'm going to set it equal to a new generic math, and I'm going to go and store the value 5.0 initially. And then let's go ahead and go and print out that value. So I'm going to call it generic.printValue. And I'm going to go ahead and run my code. So I get this value 5.0 back. Now, one of the issues that we saw with using objects when we were working with our bag is that I can store whatever I want as an object. So I could say here that call generic.setValue, and I could go and set it to the string WVU. And that's going to work too. You can print out WVU. This is going to be problematic though later on if I'm trying to go and do math, because I can't really do math on a string very easily. So what we want to do here is have a solution so that we can't change the type of our value once we get things started. That'll be kind of our initial first run at this. Generics are great for this because what we'll be able to do is specify the type for our value field here, but we can also go and set it up so that for our constructor and when we call like set value, they all have to be of that same type, so that if I go and create this so that it's going to store a double, I can only set it to another double. I can't set it to a string or something like that. Let's go ahead and begin by making this class be a generic. And what I'm going to do here is right after the name of the class, I'm going to put a set of angle brackets. And I can do this as to an interface as well. It's not just classes that we can go and specify this on here. Inside the angle braces, I want to go and give the name of the placeholder I'm going to use for the type. That's going to be our generic type. It's pretty common to use single capital letters starting with T for type for this purpose here. Even though it's generally bad practice to go and use single letter variables, kind of like when we're working with loops, it's sort of understood that, like I is a lot of times a counter in a loop. T, capital T, tends to be used for a type as a generic parameter. If we need to have additional generic parameters, we can separate them by a comma. It's pretty common to do letters after T, so like U, V, W. Or we could do like T1, T2, something like that. In our case, though, we just need one generic placeholder. So we're just going to use T. And what I'm going to do is go through my code here, and any place that I want to have it go and substitute in the type that I'm going to specify when I go and instantiate generic math, I'm going to change that type to be T. So every place that I've got object here, I'm going to go and set to T. I'm going to head back over to my main method now, and you can see we have some warnings that are going through and popping up here. If I go and look at where I have these mentions of generic math with both calling the constructor and then defining the type here, it says generic math is a raw type. References to the generic type, generic math, and then T as our parameter should be parameterized. What that basically means here is that Java is looking for us to go and specify the type for our parameter. So we're going to go ahead and do this. When I go and call the constructor, I want to go and specify the type there. Now you'll notice here that I used capital D double, which I go and hover over here. It tells me it is this class java.lang.double. This has to deal with a limitation of generics. If I go and use the primitive type double, it's going to go and give me an error here. It mentions using a reference type. Same thing happens with int. Generics don't allow you to use primitive types. You need to go and use the wrapper for that primitive type. So instead of int, I would want to use integer. If I want to go and use double instead of lowercase d, I want to use capital D double. String is already a reference type. We don't need to worry about a wrapper for that. Any of the classes that we would write ourselves are reference types. So we don't need to worry about wrappers for those. It's only the primitive types like Boolean, int, double that this becomes a concern. So I'm specifying capital D double here. So we're going to go through and use this type as the value for our constructor and for when we call set value, and then also what it's going to return when we call get value. The reason why when I had integer typed in here, this throws an error is because it's going through and expecting an integer, but I'm giving it a double. If I were to go and change that to an integer, we'd be fine. You want to make sure that when you define a variable that's going to go and store your object that has a parameter in it, that you go and specify the parameter with that as well, so that everything goes and plays nice. Right now I kind of have this weird situation here where I'm taking this one that's a double and I'm going through and specifying it to be stored in just this generic math here that doesn't have a parameter specified. So it's going through and throwing a type safety warning here when I try to set a value that's going to be a string. If I go and run my code, it actually runs. But that's not really what we were intending to do. We wanted to make sure that we can only go and store doubles in there. So what I want to do here is when I'm going and storing it in a variable, I'm going to specify this one is of double. So the parameters should match. And now once I've done that, I start to run into an issue here with my set value. Because it sees that this is a double, it knows, hey, you should be passing double for set value. So now this is going to throw a compile time error, which is a lot easier to catch than if it was a runtime error. As long as you're running Java 11 or newer, the easier thing than having to go and worry about specifying the parameters is just to specify var for the type of the variable. It's automatically going to go through and pick up whatever it should be here by inference. So it doesn't allow me to go and compile and run my code here with WVU for the value I'm trying to set, because it knows that it's not applicable for when I go and use double as the type here. Now if I went and changed this to a double, like 3.0, it'd be perfectly happy. It'll allow me to go and set that, and it'll go and print it. If I were to go and change things so that I was storing a string instead, it'd be happy with that too. The key is that all the types have to go and match. And that's really the power of the generics, is that you get those benefits of compile time type safety, that you're doing the right type that you're storing, you're getting compatible values and things, and it happens at compile time, not something that's going to throw out an exception when you're going and trying to run your program. As we have things set up right now, this type T can really be any type. We're not placing any restrictions on this. We could store an object if we wanted to. I've seen that we can do integers and doubles and strings. There's no restrictions on this. That poses some challenges here. We may have cases where we're trying to go and do certain operations where we're expecting something to be of a particular type. For example, this is called generic math. Maybe I'm going to do math on this, so I want it to be a number. We also see a case here that if I go and take a look at my variable that I've defined to be of type T, so if I take a look at this dot value, I don't have a whole lot of options on what I can do with that, because it's going through and treating this as being an object here, because that's what it can be. That's the lowest case that it can be. If I want to do math, perhaps I want to go and be able to get the double value of this. I can't do that right now. What I'm going to go and do is place a restriction on what type T can be. And I'm going to do that by going and using the extends keyword here. When I go and extend things, I can specify a class or an interface. But what this means here is whatever type I'm going to go and pass in here needs to go and implement the methods that are in what I go and specify. So if I want to go and make sure that this is going to be an actual number, I can tell it that it extends number. There's this type java.lang.number that the wrappers for double and integer and the other types all inherit from. So if I go and do this, I'm only going to be able to specify a number. If I go and take a look here back in my main now, where I'm trying to tell it that I want to do a string, it's no longer going to allow me to do this here. It says that the type string is not a valid substitute for the parameter, because string does not inherit from number. I can't use it. So I would have to go and change it to one that does, like double. We'll go and switch this back to double here, and then we'll go and fix our set value. So now that I have these back as double, everything goes and works fine. By going through and placing this bound restriction here, it's also going to allow me to access any of the methods that are defined in this class or interface. So now I can do this dot value dot, and I get a whole bunch more methods because they're things that are available through number. It knows that it can't be an object. It knows it has to at least be a number. So it's going to give me access to the methods that are available with the number class. So if I wanted to do math, I could go and get the double value of things here, for example, and go and add stuff. When we go and specify a type here using our parameter, it goes and makes sure that all of our type safety requirements are met at the time of compile. That doesn't mean that the type that we specify gets compiled into the final code, though. Java went and added support for generics after it had already been around for a while. Generics were added in version 5.0. And they wanted to avoid breaking existing code. So the way that generics were implemented is a little bit weird. They went and used something that's called type erasure. What that means is that when you go to compile your program, it's going to look at the type that you specified. So like with my code here, and it's going to look at double and make sure that everything that is supposed to be of that type is a double. But when it actually goes and compiles the code, it doesn't go and compile saying that those variables were double. It's going to use the lowest possible type they could be. So since we said that T extends number, it's actually going to compile in as being number. If we didn't say extends anything, it would go and compile in as object. What that means is that when my program actually goes and runs, it's going to go and figure that that variable is of whatever is compiled in. So it's an object or a number, not a double, even though that's the parameter that I went and passed when I called the constructor. This has some limitations that are going to show up with potential errors that can occur at runtime. You can run into problems if you're going to go through and try to cast variables. Sometimes they may show up as being invalid casts because it doesn't really know the true type that you're dealing with. This also shows up when you're trying to go and make arrays. It's challenging to go and make arrays in Java when they go and involve a generic. So some challenges just to be aware of. Now that we've seen a bit about how to use generics, let's apply them to our bag. In fact, data structures are one of the most common cases where you'll see generics used in coding. We can go through and use generics to control what type of items we want to be able to store in our data structure. In our case, what we're going to do is take the code that we wrote for bag interface and array bag, where we're going and storing objects, and we want to convert that code so that it goes and has a generic parameter where we can specify the type of item that we want to store. Let's go head over to Eclipse. To modify our bag implementation so that it takes a generic type parameter so that we can specify what type of data we're storing, we're going to work with the generic array bag project that we imported as part of the starter code. This project's code is essentially the same as what we ended up with our object-based implementation of the bag. And I'm going to start off by going into the interface. We're going to have to change the code in our interface and class so that they go and use a generic type parameter so that we can actually specify what type of data we're dealing with. We'll also need to go and modify our main class where we're going and instantiating an instance of the bag to provide the type parameter there as well. To specify the type parameter, I'm going to go right after the name of my interface, and I'm going to add a set of angle braces. Inside there, I'm going to add an identifier for my generic type. So I can basically name these more or less whatever I want, but convention is capital letters and just single capital letters. Now, with a bag, we're only storing one piece of data for each item in the bag, so I only need a single generic type parameter. But if I had a case where I would need to be able to specify multiple types for generics, like say if I'm dealing with a dictionary where there's a key and a value, I can go and specify multiple type parameters just by separating them with a comma. T for type is most common. If you're going to start off with T, it's pretty common to go and just increment up to the next letter. So if I had 2 parameters, it'd be TU. If I had 3, it'd be TUV, and so on. In this case, though, I just need T. I want to go through the interface here, and every place where a method goes and either accepts an object as a parameter or goes and returns an object, I'm going to replace that with the T identifier for our generic type. So like now, add is going to take an item of type T. Same thing for contains, count of. The version of remove that doesn't have any parameters is now going to return an item of type T. The other remove will take a parameter of type T. And I'm also going to go and change toArray to return an array of type T. That's a little complicated, and we're going to talk about that more in a moment because there are some pretty significant issues with using arrays with generics in Java. I'm also going to update my ArrayBag class. Where I say that it goes and implements bag interface, I want to go and add the caret sign T there. And in this case here, the caret sign T is because I'm going to go and use caret sign T after the name of my class. So ArrayBag takes a generic of type T here. That generic of type T parameter is what is passed on the bag interface. So this is T here because it's T with ArrayBag, not because it's T back in the interface. What I want to do now is go through this class, and for the fields and methods that go and use the object type, I'm going to go and substitute T. So for example, our bag is going to be of type T. We're going to skip over where we're going and instantiating the array here. We'll come back to that. But like add now is going to take an item of type T. Contains and count of, we're also going to change to T. For remove element, that helper method, it's going to return an item of type T. The plain old remove method is going to return an item of type T. Get index of will take a parameter of type T. Remove is the other version of remove is going to take a parameter of type T. And toArray is going to return an array of type T. Now let's go back up to our constructor here, and we need to deal with this case where we're going and creating our array. One limitation of how Java handles generics is that I can't do this. I can't go and make an array of a generic type. Some of this has to do with just the way and the timing that things were implemented. There was not a good backwards compatible way for Java to support this, so they just chose not to. The best that I can do is go and create an array of objects, and then I can go and cast that to type T. Now this has a little bit of a limitation of its own. If I go and hover over it here, I get this message that I have an unchecked cast from object to T. And this actually comes into part of that type erasure thing that we were talking about earlier. Once this all gets compiled, there's not really going to be a way that Java's going to know how to make sure this is actually really safe. So it's going and giving me this warning here. What I'm going to do is go and just tell it to suppress this warning here. It goes and adds this suppress warnings decorator here to the method, and that goes and turns off that warning about things being unchecked. Still is potentially unsafe, but the reality is I should not have any problems with it. If you notice on the Problems tab down here, I have a whole bunch of warnings that are showing up coming from my main class. They all have to do with the fact that we have added generic parameters to our interface into our class, but we haven't updated our code that actually references those to add parameters there. So it's going through and saying, for example, that's a raw type. That means that I'm going through and calling a class or an interface, but I'm not providing a generic type for it. Let's go and fix these errors. I'm going to go to my main class, and where I'm calling bag interface, I want to specify what type of data I'm storing. Our case here, we're storing strings, so I'm going to specify inside of angle braces the generic parameter as a string. If I had multiple generic parameters on a class or an interface, so if I had like that t comma u, I would just specify the different types with a comma separating them here. I need to make the same change over on the part where I'm going and creating the class. As soon as I go and make those changes, all those warnings go away, because now it knows that these are supposed to be strings all the way throughout. Let's go ahead and run our code and see what happens. So it goes and checks successfully to see if Charleston or Beckley there, and it tells us how many campuses we have. But I get an exception, a runtime error, down at line 27, where I'm going and calling the toArray method. It says that basically here an item of type object cannot be cast to the class string. This is one of the shortcomings that you can run into between the interaction with arrays and with type erasure in how Java goes and handles generics. If I go and hover over these items here with the var keyword, you can see that it thinks it's a string array, and it thinks that toArray is returning a string array. So you would think it's not actually trying to do any casting there. What's going on is that if I go back and look in my array bag class, and I go down to toArray here, I'm returning array of type T, and that's going to be string. It's going through and returning this as a copy of whatever the underlying type is. The problem becomes, if we go back up to where we create that array in the constructor, that array is of type object. We're doing this cast here to make it a string array, but by the time type erasure happens, that cast kind of just gets forgotten. It's actually going through and casting it back to an object is effectively what's happening. So it's saying, hey, you've got an array of objects, you're trying to cast it to an array of strings. I can't go through and do that cast because I don't think it's necessarily going to be safe, at least from Java's perspective. Java, because of type erasure, not realizing that it's got strings all the way throughout. So there are a couple of solutions that I can look at for going and solving them. One thing that I do just want to go and point out here, if I just do a cast, for example, to go in and cast the array that comes back from copy of, that doesn't solve the problem. Going to my main and going through and casting to a string array here doesn't solve the problem either. Nor does going through and saying that this is a string array instead of just using var with type inference. The solution that I can go ahead and do here is to go and say that this is going to be an array of objects. And so I'm explicitly here saying that it's going to be an array of objects. Now my code runs correctly. So it knows it's an array of objects. Each individual item, when it goes and peels it off with the for each, if I go and call getClass, it knows that the individual items themselves are strings, but the array itself it sees as an array of objects. So you kind of get some weird behavior here. It's sort of painful to have to remember that I've got to explicitly say that this is an array of objects, and I can't use the var keyword. So what I'm actually going to do here is I'm going to go back to bag interface, and instead of having this be an array of type T, I'm going to have this be an array of objects. And I'm going to make a corresponding change for that here inside of my class. You can see my code still runs. We get the names here. If I go through and use var instead now, it's going to go through and see this as being an array of objects. So I can go ahead and run it. We're good. I don't have to go and explicitly list the type. When you're working with the data structures that are provided as part of Java's standard libraries, you'll see that the toArray method normally goes and returns an array of objects for this very reason. There's an alternative solution to using an object type array, and that is to go and use something called reflection to go and create an array of the specific type that we're interested in. With that solution, I have to go and know what type of array I'm going to use, and that's going to have to be passed in as its own separate parameter for my constructor in this case. So what I could do is go and write up something like this. I could go through and say that this.bag equals, I got to go and still do a cast here, java.lang.reflect.array.new instance, and I need to tell it what class it's going to be. So I could say here I'm just going to hard code it since I'm not providing it as a parameter, and then I can specify the capacity. That will go and make an array that is actually of type T. This is really messy though, and I have to go and then pass in another parameter when I go and create my constructor. I can't just rely on the generic alone. So because of that reason, you normally don't see this used. What you do generally see done, though, is providing a way that we can go and get an array that is of the type. It's just that in order to go and get that array, we're actually going to have to give it an array of our type. So let's go head over to the interface, and we're going to create another version of toArray over there. Here in my interface, I'm going to go and add a version of toArray that goes and returns an array of type T. It's also going to take an array of type T. And I'm going to go and call this parameter destination array. We're going to say that it exports contents of bag to provided array, and destination array is the array to store contents of bag in, and we're going to return array with contents of bag. Let's go over to our class here, and we're going to go and implement that new method that we just said. I'm going to go and add the override tag for it here, and I'm just going to code it up. It's got a public access modifier, return type is TArray, the name is toArray, and it's going to accept an array of TArray called destination array. Here for this method, what I'm going to do is I'm going to go and use this array to store the results. I'm not going to go through and create a copy of the existing bag. I'm going to go and copy the values that I've got in my bag into this array. If this array is not large enough, I can go and make a copy of this array, and it's going to pick up the type correctly. So let's go ahead and code this up. I'm going to first of all make sure that the destination array that's provided is large enough. So we're going to create a larger array if needed. So we're going to go through here and see if destination array dot length is less than this dot size. Then what I'm going to do is set destination array equal to an arrays dot copy of it. So I'm going to say java.util.arrays.copy of destination array, and I'm going to make it be this dot size big. So this is going to go through and give me an array of the type that I actually want. I'm going to set all of the items inside of that array to be null. And I know that I will be able to safely do this because T, since it's a generic parameter, can't be a primitive type. it's going to have to be a reference type, and a reference type can take null as a value. The reason why I'm going and setting everything to null is just so that if there are any values there already and that array is larger than the size I actually need, I don't have any existing values lingering around. So I'm going to set all values in destination array to null. So I'm going to go and call java.util.arrays.fill, and I'm going to tell that I want to set destination array to null. And in fact, I'm actually going to put this inside of an else clause, because if I create a new array, it's automatically going to have everything be null. The only scenario where there might be values are if I'm using the existing array. Once I know I have an array that's ready to use, I'm going to go and loop over the contents of my bag one by one and go and copy them over to my destination array. So I'll do a for loop here. We're going to say int I equals 0. We'll loop while I is less than this.size, which is the number of elements that I'm using, incrementing I every time. And I'm going to say that destination array sub I is equal to this dot bag sub I. So I'm going and copying the values there. And then when we're done, we're going to return destination array. Let's go ahead back over to our main class, and we're going to make use of that new version of toArray. I'm going to go and pass it an array of strings. So I'm going to say I want a new string array. I don't actually have to store it in a variable first. And I'm going to tell it that I want to have 10 spaces here. Let's go ahead and run this code. You can see that I have my 5 values, and then there's a bunch of nulls after. If I go and take a look at things here, toArray is returning type string. Campuses is of type string, for they're actually both string arrays. So this actually gives me a real string array and not just an object array like with the previous approach. If I go through and provide an array that's not large enough, so like say I've got 1 element in the array that I'm providing and there's 5 things in my bag, it's going to go and make a larger array that's big enough to hold what I have in my bag and no larger because of how I coded things. So I get my 5 values and there's no nulls afterwards. This version of toArray is a little bit nicer in that we actually get an array of the type that we want, but it does have this extra parameter, a little bit of an additional hoop that we've got to go through and jump through. Now, like I said, there is still some type checking. Now, I do have to manually go and specify its string here, but for example, if I go and say that I'm trying to make an array of integer, you can see it's actually going to throw an error right here because it knows that integer is not the generic type parameter that I'm actually specifying up here as string. It goes and follows that T and knows that things don't line up. So it prevents me from making mistakes with mismatched types that way. I tend to generally prefer this approach in most cases, but you know, like I said, there is a little bit more coding here. If you go and look at a lot of implementations of data structures, you'll see that both are included, just as a convenience to the user. For this lecture's participation project, we're going to build upon the generic math class that we created as part of the lecture. I provided a version of this in the starter code that's posted in eCampus for this participation project. Inside the generic math class, I want you to go and create a new method called printAdd. It's going to take a parameter of type t, and if you look at the code, you'll see that in generic math, I have the t generic parameter restricted so that it must go and extend number, which means basically t has to be one of the number types, so like an integer or a double, something like that. I want you to go and add the value of the parameter that we passed to printAdd to the existing number that's stored in the value field. And I want you to go and print the result. I have a note here that you do not need to update the stored value, just print the result of going and adding things together. One big thing you're going to have to think about here is how are you going to get something from that parameter and from the field that you can actually add together, because by default you can't just add a t-type variable plus a t-type variable. But if you go and look at the methods that are provided by number, you'll see there's a method there that's going to allow you to get a floating point representation of that value. That's what you're going to want to add for each of those two values. When you turn this project in, you don't need to provide a class that instantiates generic math. I just want your updated generic math class. That's where we're going to end things for this look at an array-based implementation of a bag. We're going to continue on in our coming lecture by looking at how we can do a node-based implementation of a bag. If you have any questions on this material, please join the Q&A session or send me an email. Thanks, and have a great day.